Alright, so for our original lesson we did workplace and apprenticeship 10.6 Pythagorean Theorem, and we focused on the outcome, apply understanding of the Pythagorean Theorem to solve problems, and on the indicator model, including the use of drawing, the meaning, role, and use of Pythagorean Theorem. So we focused on the proof of it and what the Pythagorean Theorem actually meant. So we have our prior knowledge, mathematics 1 to 9 strand, shape and space. Students will have prior knowledge of the concept of the Pythagorean theorem, and students will know how to solve an equation for a variable. So we had our main essential questions here. What is your understanding of the Pythagorean theorem, and what are the current and historical uses of the Pythagorean theorem? So we figured that students will need to know and understand the meaning of the Pythagorean theorem, so what the actual proof means, and that students will understand the role of the Pythagorean theorem, and they'll apply that to the area of mathematics and society. And so they'll be able to relate the above knowledge to other mathematical or life situations, and that they'll be able to apply the Pythagorean theorem to situational questions. So for our acceptable evidence, kind of our assessment here, our performance task, we wanted them to fill in an exit slip so that we could kind of see their thinking process and see the connections they made between the Pythagorean theorem and real life. We also thought that we would use visual assessments and visual clues to ensure that students are on task and are understanding, and that we would discuss and brainstorm input from the students at the set, because we thought that to kind of get their minds going onto the concept of the Pythagorean theorem. So the learning plan. This is kind of how we wanted our lesson to go. So before, since the students have already seen the Pythagorean theorem, we wanted to brainstorm examples of what it was and how they would use it. So kind of a little bit of recall, get their minds going on what this Pythagorean theorem is. But we wanted to focus more on the understanding of the Pythagorean theorem. So start off the lesson with brainstorming. What does the Pythagorean theorem mean? We would write the student responses on the board. So after that, after we got their mind going a little bit, we would have the discussion regarding what students now think the Pythagorean theorem is after they watch this video up at the top here, and why we would use it. So have them watch the video, maybe they'll get a better understanding of what the Pythagorean theorem is, and then have that discussion after using these two essential questions here. What can you now tell me about the Pythagorean theorem after watching the video, and why is the Pythagorean theorem important in the modern world? And then we would go on after that discussion, give another example of the Pythagorean theorem in a situational context. And we have the Pythagorean theorem and the roof framing question. So the roof framing question was a diagram of what a roof looks like, and have them apply the Pythagorean theorem to that. So after that example's been done, and students have kind of guided me through how they wanted to complete that question. Before they left, we would have them complete an exit slip that has a picture of a manual from 1258 Islam on how to use the Pythagorean theorem. So this is a very unique piece and proof of a theorem from Islam. So we asked them the questions on this exit slip to see how much their understanding has changed and see how well they can apply it to real world situations. So we'd ask them the question, what differences do you see in this proof compared to the one we saw in class and on the video? And what do you think those differences mean? So it's important to have them compare and contrast the two, and understand why they might be different and if it really changes it that much. Why do you think the Pythagorean theorem was important in 1258 and even before that time, since it was derived by Pythagoras in the 6th century AD? And what do you think its uses were? So kind of a historical context. Why was it so important in 6th century? And what is one question you now have about the theorem? So that was our original lesson plan, more of the understanding of the Pythagorean theorem. And Ali will tell you guys about our lesson study and what we revised.
Okay, so I'm going to be going through what we changed in the lesson plan. For our prior knowledge, we thought we should make sure we went more specific into what students should know, so that the Pythagorean theorem can be applied on right triangles, rational and irrational numbers, and exponents and square root properties, that they should all know that beforehand. So just being very aware of what they should know. Our essential questions, we also asked how is the Pythagoras theorem formed? Because at the beginning we showed that video of the Pythagoras theorem and how that is created through the squares that are built off each side. So we thought that not just understanding, but actually how it's formed. For skills, again, students will be able to show how it's formed itself. Not just understand it, but be able to do it themselves and see it and then explain it and be able to explain how besides this and then how it's a squared because it's a square, right? So you'd find the area of the square that's on the side. So, as well, for other evidence, we'd want to do a diagnostic evaluation prior so that we know what students already know about right triangles, rational numbers, part of the prior knowledge, so we know where students are at. For the before, we'll write students' responses on the boards and brainstorm making a concept web. So instead of just what does the Pythagoras theorem mean and just asking, we could put on the board so that we have a concrete visual of what it means, what they already know about the Pythagoras theorem. For the video, pause the video to discuss questions and understanding throughout the video, just so you know what students are thinking, what they are seeing, do they understand what the video is presenting. For discussion, we also have students come to an understanding how a squared is the area of the square that you expand from the triangle, and have students come to an understanding of why a squared plus b squared will equal c squared. Instead of just showing it, have them come to that understanding that that's what that means, all the squares that come off both sides. And also shows for the roof example that we'll be giving, instead of just giving students a diagram, we'll actually have an actual roof example, so it's more real life situational. Yeah, they can have a discussion about where it would be used, and so it gives more of a real life scenario instead of just a diagram that says this is a roof. I think that's all we did to change our lessons. So that's our lessons.